in this geometry construction, we are going to construct the inscribed circle of a triangle, which means the circle that we are going to create is going to be totally inside the triangle. So this construction is based on the angle bisector properties. If we draw all three angle bisectors in a triangle, they intersect in the point of concurrency known as the incenter. The incenter is the center of the circle that is inside the triangle. As a result, the incenter is equidistant from the sides of the triangle. So to do this construction, we just need to construct our angle bisectors. Technically, there are three angle bisectors, and your incenter is at the intersection of all three. But if all three intersect at one point, two of the three are going to intersect at that one point as well. So we will begin by constructing our intersections. So our intersections of our angle bisectors. We will start with this obtuse angle down here and construct our angle bisector. So we begin by making our reference angle. From there, we are going to move our compass to one of our intersection points. We go beyond halfway already, so we draw our arc above. We do it to this intersection, we switch, and we do it to our other intersection as well, drawing our arc above and below. From here, we have to connect and draw our line for our angle bisector. We are connecting our vertex to the angle bisector, and that is our first angle bisector that we have constructed. So we have one angle bisector so far. Next, we are going to construct our second angle bisector. So I'm going to change and make our second angle bisector green. So we're going to go over to this vertex, and we are going to draw our reference arc. Then I move my angle up here, my compass up here, and I'm going to extend it to make sure I go over halfway. That looks good. So I'm going to draw it inside on this side, switch, and repeat on the other intersection as well. Then I am going to connect these two pieces to draw my next angle bisector. So this is my angle bisector, and from here I am going to measure my distance to the side of the triangle from the incenter. Now, the most accurate way to get my distance to the side is by creating my perpendicular through a point not on the line. So if I do that, I'm going to place my compass at the incenter. I'm going to make my arcs down here. I have to make sure that I'm going to intersect this side. Whoops. I'm going to make sure I intersect this side in two places and draw an arc. Oh, sugar. Put that angle bisector back where it goes. And I'm going to make this a little bit smaller. So we're going to delete this one and make it a little bit smaller since I'm not going to extend my side. All right, so we intersect in two places. I'm going to make sure my angle bisector goes back where it needs to go. All right. From here, I'm going to make my perpendicular, so I'm going to go here. Switch to this intersection and there. So my perpendicular line will go through this point and that point. And I'm going to fix that to make sure it's straight so we can measure our perpendicular distance. All right, what we've done is we've adjusted due to some of the error that we have just naturally in the computer and creating all of these lines. But next step, after we make our perpendicular, then we are going to measure the distance from the incenter to the side along the perpendicular. This is the radius for our circle. When I draw this, my circle should be relatively close to being all the way inside of the triangle. So this will be a blue circle. Okay, so there's my blue circle that is supposed to be my inscribed. Get rid of that arc that we had from earlier. This is supposed to be my inscribed circle. It's slightly off. That's just from the general error when we are making the lines and drawing all the intersections and adding lines on a screen. But in order to make your inscribed circle for your triangle, you just have to create the incenter, which is the intersection of your angle bisectors. This is one of the hardest ones to do because of all of the lines that are associated with this construction.